The significance of this protocol is that it introduces a label-free imaging technique capable of acquiring high-contrast images at high frame rates that is simpler and cheaper than other techniques like DIC and dark field.
The main advantage of this technique is that it's easy to implement and it's easy to use. It's inexpensive and it can be combined with fluorescence microscopes easily. The method was developed for visualizing individual microtubules. It has the potential to be used for visualizing large protein complexes and nanoparticles.
The main difficulty is the activation energy required to tinker with the filter cube to add the half-silvered mirror. My advice to someone who is trying the technique for the first time is just do it.
To begin, insert a 50-50 mirror into the filter wheel of a fluorescent microscope using an appropriate filter cube. Handle the mirror with care, as often they have an anti-reflection coating. Turn to a high magnification objective that also has a high numerical aperture. The one shown here is a 100x oil objective with a numerical aperture of 1.3. Next, use a razor blade and a microscope slide as a straight edge to cut 3 mm wide strips of plastic paraffin film. Place 2 of the plastic paraffin film strips 3 mm apart on a clean 22 by 22 mm cover slip. Then, place an 18 by 18 mm cover slip on top of the strips to form a channel. Transfer the cover slip to a heat block at 100 degrees Celsius for 10 to 30 seconds for the paraffin film to form a sealed channel. Using a pipette, flow in 50 micrograms per milliliter of an anti-rhodamine antibody by perfusion and incubate the slide for 10 minutes.